So here's a quick video to help you get started on the light bulb resistance lab. So when you open it up, you're going to see a whole bunch of things here. There's, I think, 7 pages, and what you need to do is fill this out on Notability. So the question of this lab is, what is the resistance of the light bulb? So there's different light bulbs that are used to measure here, and we want to find out what those values are under different conditions. So the procedure here, we need to measure voltage and current in this circuit to find out the resistance, because we can't measure the resistance directly while the circuit's powered. So to help you with that, look in the Schoology here. There's some procedure help, and they give you some descriptions about how you measure voltage and current. Make sure that those definitions make sense to yourself, especially when you look at how they're hooked up in the diagram. So once again, voltage is across something, you got to touch on each side. Current, we have to measure the electricity going through the meter. So make sure when you're reading these and writing them down in your Notability that they make sense to you. If you want to just copy them directly, you can, but really try to make sure that you're making sense to you, because this will help you on the test that's coming up in a couple of weeks. Also then, once we do have voltage and current, we can divide them to find the resistance. So that's what we're going to do in the lab. And also, once we have voltage and current, we can also calculate the power. So that's what you're going to do in the lab here. Now, to get your values for the lab, like in case 1 here, you can read the values off the pictures, or you can also watch the video that explains them. So as you go through and watch this video here, it goes through some tips on how to measure. So watch that whole thing, and then also look later on where they explain the circuit, watch it, and get the numbers from there. And so once you do that, you can put your numbers in here. And so for us, the first one, they ask you about the light bulb. We want to compare the brightness. So here you can quick see how bright it is here in case 1. Look down in case 2, not as bright. In case 3, a little bit brighter. And then you want to make a comparison of those. So for me, I think this one definitely is the brightest, and I can write that in. So you can say it's the really bright, it's the brightest. I'll just put really bright. All right. And then we need the voltage and current. For the first one, if we look at those values, the voltage was 6.72 volts, and the current was 171.2 milliamps. All right, this milli is going to be important because it means 1,000th. All right, and we can't just put 771.2 in. We need to remember that it's in thousandths of amps. All right, we can also find the battery voltage. If we look, that was a little bit later in this video here. Let's see if I can jump ahead to it for you. Oh, start it over. So this here is explain the circuit, and then I need to wait for it to load a little bit here so I can jump ahead. And there it is. So 7.79 when it's just the battery hooked up. So I can go back in here into my lab and put this down here, 7.79 volts. All right, and the next part here is I want to find the calculation. So if I look at this here, oops, wrong one. If we try to get rid of my picture, which is supposed to be possible, I'll just move it up. There we go. All right, to find resistance, we said in the procedure that it's going to be voltage divided by current. So we can write that in here. It's going to be the voltage divided by the current. And so when I put my numbers in here, I can write those in. The voltage was 6.72 volts. And the current was 171.2 milliamps. Milliamps means divide by 1,000. So I got to move the decimal point over once, twice, 3 times. So it's actually, for my numbers, I'm going to be 0.1712 amps. So now I converted from milliamps to amps. And then you can do the math on there, and your answer will be in ohms. So you got to do 6.72 divided by 0.1712 amps. And that will give you your value in ohms. The same way for current. It's going to be the power is going to be the current times the voltage. And if I plug my numbers in there, again, I have to put in the 0.1712 amps because I'm going to move that. I want to be in amps, not milliamps. So I got to divide by 1,000, which means the decimal point gets moved over 3 times, and then multiply by my voltage, 6.72 volts. Oops, got 6.72 volts. And when you do that answer, when you do amps divided by volts, you'll get an answer in watts, and that's what we want to compare. So once you get all those done for the different cases, case 2, you have to do it twice, once for each bulb, and then you do the calculations twice for each bulb. And case 3 is also 2 bulbs, so you're going to do those calculations too. Again, you can get the numbers from the pictures, or you can get it from the video. And then when you get those all said and done, you're going to take your numbers from each of those cases, and you're going to fill out this data table. So the voltage for case 1, the current for case 1, the resistance and power you calculate for case 1. All right, there's no bulb 2 for case 1, so those are X'd out. And then the total bulb brightness, you're going to write very bright, and the total light bulb power. Total means add together, so you're going to have to add up the powers. So for the first case, there is only one power, so that one's easy. For the second cases, though, total means add, so you're going to have to take the power from the first bulb and the power from the second one and add it together, and that'll be your answer here for total light bulb power. And then also for battery voltage, current, and power, you're going to have to calculate those in. So the voltage and current we measure. The power we don't calculate earlier, but you can calculate it here because power is going to be the voltage times the current that you have. So you should be able to get those through here. To find the current through the light bulb or through the battery, for the series and parallel, it's pretty easy because there's only one loop as you go around. For the series and simple circuits, it's pretty easy because there's only one loop. But for parallel, you're going to have to add the currents together. So if we look at the currents for bulb 1 and the current through bulb 2, both of those currents are supplied by the battery. So we're going to have to add those up, and that'll be your answer for the current through, through the battery for the parallel for case 3. So hopefully those go together pretty quickly for you, and it's not too bad. So I'll close that out here. So again, you know, when you look at the current, you'll have to do the current through both bulbs in case 3 and add them up. The voltage you'll have. The other one's case 2. You can see that there's only one circuit, so the current's the same for all of them, for the light bulbs and the battery, they're all the same. And the same for case 1. There's only one path, so the current through the light bulb is the same as the current through the battery. Once you get all those put together and you're looking at that table and it's filled out and looking nice, then there's some conclusion questions you want to answer. What was the resistance of the light bulb? So in there, you're going to look at all the different values you have in here. So you're going to have resistances. You're going to have actually, you're going to have 5 of them to compare. You're going to have a resistance for case 1. You're going to have 2 resistances for case 2. And 2 resistances for case 3. And so you're going to want to look at those and compare them and see how that all goes together. The resistance was constant, so if the resistance changes, that would be a no. If the resistance are all the same, then that would be a yes. And then we want you to look at, does the resistance depend on the power used by the bulb? And then give a brief thought, what could explain that change? So when you look at the powers in the light bulbs versus the resistance, maybe there'll be a pattern. So when you look at the resistance in case 1 and the power in case 1, and the resistance in case 2 and the power in case 2 and case 3, you might look for a pattern there and try to explain that. All right, so you guys fill this out. Hopefully it'll go well. We want it done by Friday so we can discuss the results on Monday. If you want to take the weekend for a little extra time, that's okay with me. But please try to get this done by Monday so we can discuss it together in our synchronous meetings next week. Good luck.